Here in this problem, we are finding what would be a good option to invest this $50,000 for Cindy. It says Cindy wants to invest $50,000 and her financial planner advises her that she invest in 3 types of accounts. The first one is paying 4% interest, the next one paying 5.5% interest, and the third one is paying 6% simple interest per year. Okay, so this is something Cindy wants to put. Cindy wants to put twice as much money in the lowest yielding, least risky account as in the highest yielding account. So this particular sentence that I highlighted in pink is going to give you one of the equation. But before that, first we need to decide which one is going to be the least risky account and which one would be the highest risky ones. So if you look at the interest rates, like putting at a lower interest rates is considered as a least risky account. So I would say let X be the least risky account, and the interest rate for this is going to be 4%. So when it goes in the formula, it's going to go as 0.04. Okay, and let Y be the middle of the one, like which is the intermediate risky one, and this will have the middle interest rate, which is 5.5%. So that's approximately not approximately, it's equal to 5.5%, which is equal to 0.055 if I divide by 100. Okay, and the third one is the highest yielding but the high risk account, and that I'll call it Z, and this would be the highest risky account, which is the highest yielding account too. And for this, the interest rate is 6%, which is equal to 0.0406. Okay, so first of all, I need to create, I have 3 variables, so I'm looking for 3 equations. So how do I get the 3 equations? The first one is, since the total amount invested is going to be $50,000, and since it's going to be distributed in X, Y, and Z, I can write one of the equation as X plus Y plus Z is equal to 50,000. So this I can call as equation number 1. Okay. The next equation is here. In the last sentence it gives me a clue that she needs to receive a total annual return of $2,400. So this is if the interest paid by this account, all the 3 accounts adds up, she needs this $2,400. So the interest, if X is the least risky account and if it's paying 4% interest, then the amount that you would get out of it is going to be 0.04 times X. So that plus for the Y, for the intermediate risky account, the interest is 5.5%, so it's going to be 0.055Y plus 0.06, which is the third account. This all equal to this 2,400, and that can be my second equation. Now, since the second equation has decimals in it, I'm going to clean it up, and I'm going to multiply the entire equation by 1,000 so that it would clean up all the decimals. So this would become a 40x plus 55y plus 60z, forgot the z here, is equal to, I have to put the 3 zeros there, right? 1, 2 is there, 1, 2, 3, since I'm multiplying it by 1,000. So rather than calling that equation as 2, I'm going to call this as my second equation with the cleaned up version. Okay. Now the third equation is coming from the pink highlighted portion. She wants to put twice as much money in the lowest yielding, least risky account as in the highest yielding account. So the lowest reading account is X, least risky account is X, and the highest leading account is Z. So I can say in Z she wants to put, sorry, in X she wants to put 2 times Z. So that will be my equation 3. Okay. So I made the 3 equations. Now I have to solve it. So let me write on the side. So the first one I have is X plus Y plus Z is equal to 50,000. 40X plus 55Y plus 60Z is equal to 2, 3, 4, 5. Careful about the zeros. Okay, and the third one I have is X equals to Z. So here I can use all my skills of solving system of linear equations. First I'm going to do is eliminate the X from equation 1 and 2 by substituting the equation 3 back in 1 and 2. So plug in X equals to C in equation 1 and 2. So in equation 1, when I plug it in, I'll have a 2Z plus Y plus Z is equal to 50,000. Or I will end up with Y plus 3Z is equal to 50,000. Let me label that as equation A. Okay. And if I plug it back, X equals to Z in equation 2, that's going to be 40 times 2Z plus 55Y plus 60Z is equal to 2,400,000. Simplify it, so this would be an 80C plus 55Y plus 60Z is equal to 400,000. 60 plus 40 is 888. I'm like combining the like terms, right? 80 plus 60. Okay. Use my calculator. Let's see if it's here. Okay. So 140C. So 140Z plus 55Y is equal to 2,400,000. So this is my labeled B. Now for the rest, I'm going to deal with my equations A and B. So my equation, so what I'm going to do is multiply. Okay, we can get rid of either the Y or the Z. And in here, let me write this the other way around. 55Y plus 140Z. That'll be helpful. So this is 55Y plus 140Z. So I'm looking at equation A and A. So what I'm going to do is multiply equation A by negative 55 and add to B. So when I multiply equation A by negative 55, so I'm going to get negative 55Y, then minus, so 3 times 55, right? 3 times 55, 165, Z is equal to the 50,000 times 55. 1, 2, 3, 4. Okay, so this is the first equation, and the second equation I'm going to write it as I see. So this is 55Y, which is B, plus 140Z is equal to 2412. Right. Okay, now I'm going to add them together. So when I add these two, the y's will get eliminated. So I'll have a negative 165 plus 140. So I can go 140 minus 165. I'm using the calculator because I won't make any mistakes. Not even a simple mistake, and that's why I'm not doing it on the head. So 27, this number minus my 2, 4, 1, 2, I already missed a 0 here, right? No, right, okay. 1, 2, 3. So it's 35, negative 35. 1, 2, 3, 4. So to find z, I'm going to divide this by 25. So my z is going to be $14,000. So that is going to be deposited at the the highest yielding account, which is $14,000. Now to find the rest of it, I will have to do back substitutions. So let me write the z is equal to $14,000. So that's going to go in this column, 14,000. Okay. Now to find the x value, I can go back and plug into the equation 3. Since I know x is equal to 2 times z, x would be equal to 2 times 14,000. So therefore x is equal to this times 2, right, which would be 28,000. Now from here I can do two things. Since I know 50,000 is the total, and I can go back to equation 1 and plug it back. This x I know is 28,000, z I know is 14,000. So if I add these two and subtract it from 50,000, I'll get my y value. So therefore y would be equal to, add these two numbers, 28,000 plus 14,000, and then go 50,000 minus that. So 8,000 will be the y value. Okay. So I have my z value, then I'm using back substitution to find x by plugging it into this equation 3, and then I'm going back to equation 1, plugging in the x value and the z value. I'm getting the y value as 8,000.